Well, welcome back to Source Decoded. Welcome, Jared.
It's good to be here.
We're not using the whiteboard today because we're going to do some code, some actual on-the-computer code. Jared had a good idea that we should compare some different programming paradigms, and so you can see what's different between them and why you might use one or the other.
Well, it came from real life experience. Yesterday when I was working, I was just trying to decide, should I do more of the object-oriented style or should I do more of the procedural style? And each of them had their benefits. It was actually an eye-opening for me to see that the procedural was actually far less code than the others. Oh, even functional was pretty good, but this is real-life stuff. This came from... The first example we're going to do is not the real life. Yeah. The second one is actually pretty much from the code that I was writing the other day.
Yeah. So we'll show you two examples in 3 paradigms each. Right. I'm not sure what the plural of paradigm is.
Paradigms.
Paradigms. So we got 2 examples. We'll do them in 3 paradigms, and hopefully between the 2 examples you'll be able to pick out what is actually like functional programming and what's procedural and everything. This will all be in JavaScript. JavaScript's a multi-paradigm language that lets you program pretty much however you want. And
I think that's what's great about it, right? To me, that's what gives it some power.
Yeah. So we'll go ahead and get started. So let's start with a procedural example. What we're going to be building is a pretty trivial, just little greeting program that'll offer a greeting in multiple languages.
So mind you, we've pre-thought all of this, so you're not going to have to be burdened with a lot. And if it's too slow, we'll probably speed it up. So
yeah. So what we'll start out with is a
you try.
That's a good
and I can talk about it. So procedural is more the C style like programming. So you have structs. The structs are what you pass around to different functions, and you act on those structs with those functions. And so as you can see, we're creating this languages struct that gives us the language to a value. And then we're going to create a function in which we pass the languages struct, then a string of the language we want to use as the greeting, and then the name that we want to have spelled out. Now this is really typical in C-style languages to where you have these methods, or I should say functions, that have just loads of parameters. This is when I know I'm doing something wrong, when I'm in object-oriented programming and I've got methods that have like 16 different parameters getting passed to. It's refactor time. But this is the way that the C-style languages do it. That's the way that and it's very concise, as you can see. We're going to get this done in the time that I had to explain procedural programming.
There you go. We got a struct, we got a function with a bunch of arguments, and here's where we call it. We're going to call greet. We're going to pass in that structure. It's just some structured data and parameters saying which language we're after and a name. So if we were to execute this, we would get Hola Jared.
Just like that.
Just like that.
Yep.
Now we could call it again. And then we'd get Oi Benjamin. We could call it again with any combinations of languages or names, and it would work. All this code will be posted. There's a link to the GitHub repo below. You can check this out for yourself. Okay, so that's the procedural way of doing things.
That's correct.
Let's go and do this object-oriented style.
Now you'll notice that while he's typing this out, the object-oriented is actually more verbose to get started. But I personally think it's easier to augment functionality in the end. So as we're going through this, what are the benefits of the procedural? What are the benefits of object-oriented programming? And then lastly, what are the benefits of functional programming? You see in like the object-oriented programming, you actually have a lot of this data. For example, in the procedural one, we had this kind of dangling languages structure Inside the object-oriented programming, we have the greetings in an object. It's really like our languages in the first one, but it's inside of the greeter. So all we have to do is we're going to register a language. It's then going to save that language with its greeting to the greetings hash, and whenever we greet, we just simply pass in the language and the name, and bam, we get the hello, or the greeting. The beautiful concept about this, in my opinion, is that this class is infinitely extendable right now, right? I guess you could say that for procedural, just go add more languages to the language struct. But I really love the way that this looks. You can register more languages at runtime. It's not stuck. We didn't have to know everything at compile time is what I'm trying to say. So technically you could build a UI that the users build in their own languages and add more language greetings and so forth. Whereas in the C style, the procedural programming, you could not. You have to know everything up beforehand. So this is the benefits for object-oriented for the win, in my opinion, in this case. Whoa, you're doing fancy stuff over there. Look at that. By the time I explained it, so I hope this makes sense to you. If you look through how he's registering the languages with Spanish, English, and Portuguese, I guess that's what the poor means. Right?
Yeah.
Okay, so
I didn't have time to look up the official 2-letter abbreviation codes for these.
So we improvise. So that's it. Go ahead and explain some.
All right, so we defined a class. We defined a new type. The type has one data property, this greetings hash. If we were being purely object-oriented, we probably would have a structured array of greeting types, then we'd instantiate the types. But we're just going with a hash map today for simplicity. Most languages provide one, so
so use dictionaries.
We'll just use a dictionary. Now we have this register language function that on this instance of our greeter class will register a greeting to a language and store it in the hash map.
So let's go through that first one real quick. Go down right there.
Oh, right here.
So as you're calling that, as you can see, the first argument would be
register
ESP.
language, yep. This is the language name.
And so up there in that register language, the key ends up being the language, and then the greeting ends up being the actual greeting.
Hola ends up as the greetings. Now we've got that stored in the hash. Okay, we'll do that for 3 more languages, and like he mentioned when I was typing, it'd be really easy to
spell that correctly. Let's do Tagalog. So tag, and then you'd say K-U-M-U-S-T-A. Kumusta.
Okay.
There you go.
There we go. So yeah, it's really easy to just tag those on, and we know exactly where that is. And then finally we call greet, send the language that we want and the name that we want to greet, and what we would end up with is hola.
Oh, no, hola. This is oi.
Oh, right.
See, you gotta read that.
Compiler Jared.
Oh yeah, my brain was a crunching.
Yeah. Okay. So that's the object-oriented way. Obviously, the most
what do you think the
visible
difference
difference? Well, it's longer for sure.
Definitely more verbose.
Yep. But the benefit is that I have this greeter object that now I can come back later and extend and reuse. I could even inherit from this object if I wanted, and then I get to reuse all of this code for free.
Okay.
In the procedural version, the only reuse we have is in the greet function. We get to call it over and over again, but it's not full reuse like we get in object-oriented because we can't extend it or
and you also have to beforehand know all the language. If this was in C and JavaScript, I guess you could have people augment this language's hash, right? This language's dictionary.
That's true.
But all in all, it's usually predetermined in procedural language.
Yeah, this would be compiled and
set in stone.
Yeah, so that struct wouldn't change.
It'd be like object.freeze in JavaScript.
Yeah.
It'd be like, anyways.
Sure. I don't know what that does, but
it doesn't let you add or remove to that object.
I'm guessing it freezes an object.
And there you go. Okay, so let's move on to the functional.
Let's do the functional one. This one is gonna seem, I guess they all seem silly, but this one's just fun.
This is really silly and really fun. But what's really interesting is this actually has the, this competes with conciseness as far as with the procedural. I was amazed at how little this took to write to do exactly what we wanted it to do. In conciseness, functional programming won on this by far. And so you'll see that in just a minute. And it does, I'm not sure if you guys are familiar with currying, but this is what functional programming gives us. It allows us to return functions as well as pass functions around as parameters. But in this case, we're using it as a return value. And you'll see some interesting things. So we pass in the, as he's writing right now, you'll see that he's creating a greeter for Spanish, a greeter for English, and greeters for Portuguese. And then from there, that returned a function, so now you can invoke that function that was returned from the other function. It may seem a little weird, but there you go. That is...
It weighs exactly as much as the procedural version.
It does. It's the same...
Yep, 13.
But you know what? It does actually. It is exactly the same. But it's interesting. So let's talk about this. Why is this neat? To me, it's because it holds really that first method call to greeter is really creating scope.
Right.
You're really creating a place where it's just really lexical scoping. It's like, hey, these are the variables you're dealing with, and you're kind of like, if you look at the very top part of the greeter, you pass in the greeting, and we don't even use that greeting until later in the next function invocation.
Right.
So you're really composing your variables as you go.
Yeah, so the information about what language, the information is stored in a function. I think that's the weird thing about functional programming is that these functions store data in their scope and carry it around. Like the state is just scope. It's not always like a member variable. It's not stuck onto an object. It's just kind of in the scope of that function, and you can make those. They just appear when you make them.
Another good thing to think about that I always forget is when you run a function, you invoke a function like greeter. Whenever there's a function created inside that function is created every time, and this exemplifies that. So if you look at the first line on line 8. And we're creating that Spanish one. When it invokes this, it comes up there, and in that invocation, it's creating another function. When I was first doing this, just kind of blew my mind that when you invoke a function, and any functions that were created in that function get created again. They're not the same function. So this is really a new function inside there each time we call greeter. And you can tell because we're saving it as the English version, the Spanish version, and the Portuguese version.
Yeah. So we'll call greeter with hola. Hola will come up here as the greeting, and what we return is this function. This doesn't get executed at this point.
Yeah, that's
it's
just
still totally
set
there.
up. Yeah.
This is the thing that gets returned with greeting available inside this thing's scope.
So that's the other thing good about functional programming is there's no leaky, right? We don't have any leaky guts here.
Right.
We're talking about health, but there is no side effects because everything's contained inside of that function.
Yeah, so all of the data transfer either happens in parameters or return values.
So what's good about that? Functional programming is good at parallelism.
Mm-hmm.
Because there is no side effects, nothing reaching outside of a function, you can now know for sure. You can parallelize this, that's why they use that in MapReduce and so forth.
Mm-hmm. So we've got 3 ESP, NG, POR become functions that are then invoked. And the cool thing about this is we could even say greeter.
Let's do tag again. Tagalog.
How do you spell that?
Tagalog? Just do tag. T-A-G.
No, we're not going to save this one. We're just going to call it anonymously.
Oh, okay, I got you. So it's Kumusta, so K-U-M-U-S-T-A.
And we're going to turn right around and invoke that function again.
So we didn't even have to, so technically, we didn't even have to save that middle language greeter. You can just bam, bam.
Yeah, you could say...
And that looks really funny. If somebody's really used to object-oriented programming, they're like, what in the world are they doing there? But it's really invoking twice right in a row because we're returning a function.
So yeah, we can just make these, trash them willy-nilly, whatever. So let's talk about extensibility, reusability. We know functional matches procedural and conciseness, but how about reusability? What parts of these things can we reuse? Obviously, we have the greeter that once it's made, we get to reuse over and over again.
Yeah, so if you make just a Spanish version, you can just make it once, right? And
Yeah.
then everybody can use that from there on out.
Yeah, we can call this as many times as we want.
Running out of names. There we go.
Yeah, we get to reuse that. We don't really have any extension opportunities, although we could add some more layers of currying and like do some transformations on the name before we...
Yeah, we could actually technically make another function and have where we pass a greeter inside that function, which I think is interesting.
That's true. The unit of reuse becomes...
Composition of those functions.
In functional programming, it's like the unit of reuse, the unit of state, the unit of action. It's all just
functions.
It's all just functions.
Okay.
Yeah, so that's pretty cool. All right, let's move on to our second example.
So this is actually came to me when we're working on this. We call it the dispatcher, and what's happened is we're storing a bunch of these entities inside of our database, and so they become really just data transfer objects. They don't have any methods on them. They're not object oriented in that way, right? They're just storing data. And on this, wow, I've noticed that I have a typo too. And it's consistently everywhere.
Yeah, I'm filtering it out.
Good, thanks for filtering it out. But so we have this basically structure that has, the entity has a bunch of components, and these components have a type in it. And what we're often trying to do with our systems inside the dispatcher is to get a component by its type. And I didn't want to have all of the systems writing code to grab types out of an entity. And when I was doing this, I was like, should I do it more procedural? Because, we got DTOs anyways, so I could pass the entity in, and then pass in the type, and then it could filter it. Yeah, there you go, you found it. and then what I realized is like, well, I could do it all these different ways. Which way is the most reuse? I ended up picking the object-oriented way, and we'll discuss that in a little bit. But procedurally, yet again, got it on concise. So it's very concise and very straightforward. So with the procedural, of course, you pass in the entity that you want to act on, as well as the type that you want to filter out of the components. So let's go through this real quick, now that you've got that written. If you look at the entity, it has an array of components. Now that can have multiple components, right? You could put another component type in there called second component, with a type of second component. And that's really what we have, is there's lots of different types of components, just like that. And you're only usually interested in either one or a combination of them. And we'll talk about that in a minute, but right now we're just interested in getting them by type. Alright, so this is just getting this should be components. Get components by type, because we're getting all of them. So if we had two components with type first component, you would get two of them back. So that's that. That's procedural, right? That's the way that you would... This is a real-life example of how I would have written this for us.
I see a lot of functions here.
Yeah.
That one and that one. But why is it still procedural and not functional?
This definitely is not like purely procedural, right? The outer shell of this is procedural. The inner shell with that filter is not functional, right? They have that filter. I'm not going to go and do a for loop. Oh my gosh, that would have been a joke. Okay, we could have done that technically.
To illustrate this.
To illustrate this in purely procedural. But this is real life example, so it's a little muddied up. We're using JavaScript in this dispatcher, and I was trying to decide what the outer paradigm would be. I guess you'll have to bear with us on that. Thanks for explaining that.
Okay, so just know this is a functional concept.
And we could just use a for loop in there instead, and iterate over the components, and creating an array, and having it really verbose and really ugly and really long, but we didn't. Okay. So this is actually code right out from my code, though, so that's why it's like that.
This is real life.
It's real life.
Life is messy.
Okay, so now here's the object-oriented way. Now there's actually several different ways you can do it object-orientedly, and we'll explain that after he's typing this. But the way that I decided to do it is that you'd have this entity, had a constructor that would make sure that it had the components array inside of it, and then we're going to add methods to it, like the get components by type. Now this is really like, if this is really pure in object-oriented programming, I guess. I don't guess it's not really pure because we got that filter again.
We got that functional filter in there.
And we had to do the nasty for loop that I can't stand to look at anymore. And but anyways, if we want to do the same thing. You're returning the, hey, look at you got a typo too. It's good that you're human, Ben. Instead of filter, it's filger.
Good job.
Okay. But anyways, there's not much to this other than the setup in this is a lot more. Is what makes it more verbose than the procedural, right? Because you're having to press in the types and so forth. And but other than that, it does. We're getting the same result. Oh, you're done. There you go. Now you can console log that and get components by type. So you notice that the functions inside of the object-oriented are really methods in the class of entity. And that's the difference usually between object-oriented programming and procedural, is you include the acting on this data inside of the object itself, or the class.
And so if we want to come back and add a component,
Oh, you gotta do it outside though. You're inside, that's the other component
you're
stuff.
right. Always have to do things right.
There you go.
Components. Whoa.
That's when you should have used copy and paste, but you're just really good at typing and wanted to practice, I guess. There we go. That's now we're on par with the procedural.
Yeah.
What are your thoughts about this, Ben?
In this case, I don't know that I see that it gives us a whole ton. It's still pretty easy to add components, although this way we can add components at runtime. And I like how this is attached to the thing itself, kind of like what we talked about before. All the capabilities of the entity are actually on the entity, and if we want to reuse the entity or extend it or anything,
It's all there.
It's all there. And every time we make an entity, we get all of that logic with it, which
Right.
was the problem you were trying to solve in the first place.
Yes.
Right? So this definitely solves that problem.
So now let's go to the functional. We'll get back. We're gonna go back to the OOP in just a minute because you could have solved it several different ways, and we'll talk about that. But the functional is yet again pretty concise and interesting. It'll actually look really familiar to you from our greeting example, right? Because the first thing that we had is like the language. You return a function that then does the filter inside it. This is pretty cool.
Here's that functional concept.
That's inside that.
Where it belongs.
Yeah, this is where it all belongs. You're right. So the only pure case in this is functional.
Yeah.
Because it is using all of its.
That's why we do multiple examples.
Yes. But as you see in that top part from the function itself that we're creating the curving in, yeah, that's a good idea.
I just
copy
noticed
that.
this was the same.
It is the same for procedural and functional. It is. Because if you literally think about functionally, they deal with tuples and arrays of structs. In my opinion, maybe they do more than that, but that's more or less what it's about. So that's pretty concise, pretty nice. Does the same thing the greeting does. Remembers the scope, the variable entity, passes it into the creation of the function that it returns, and now you're able to filter out that entity.
Now in this case, we're just calling that return function anonymously immediately.
Yes, immediately.
But we could say, my entity component getter.
Yeah, I don't know what to call that. Equals get components.
Components by type. And then we could...
We could reuse that for that specific entity, right?
Yeah, we could say my entity component getter
For first component.
second
Yeah, perfect. Yeah, exactly.
Those are essentially the same, although...
Perfect.
There.
So now let's change that top, the line 23 to my so they can see how you can reuse that. Exactly. So now now since he saved that function, he's able to reuse it, right? That's where your reuse comes from.
Mm-hmm.
Is saving that as a variable. So that's that. Now let's go back to the object-oriented program style. I actually didn't pick this style exactly. And the reason for that is because, remember, we're saving these entities as DTOs inside our database. And I don't want to have to go and create another class. Like, you'll have basically a lot of memory churn. If you go and create a class, then us reassign all those variables from that. So what I created was called an entity utility. And I passed the entity in as the constructor, and then it just acts on those entities.
Oh, I see.
But what's interesting, go ahead, were you going to say something?
I was just going to point out that DTOs can't have, they're just data packets.
They're structs.
They can't have any functions or anything on them. They're just...
And since we don't want to do a lot of memory churning getting this data from the database, that's why we keep it that way.
Yeah.
So what's neat is I created this, if you go here and say entity utility, you'll see how this works. And you pass in the constructor the entity that you're working on, and then say that to the there you go. And now instead of saying this.components, we say this.entity.components on the filter. And now you're there.
And when we make an entity, we're going to say...
Oh, you don't even make it. You already have it, a lot like we had in the procedural and the, that thing, the DTO you copied from here.
Yeah, but we have to pass into the constructor here a DTO.
Oh yeah, that's right.
Like this.
You don't get it. Oh, not like that. You need the whole entity, not just the components part.
Oh, this whole thing.
Yeah.
I see.
Because that's what's in the database.
So we would do this, and then we can not have to do that.
Yep, that goes away. Then that becomes entity utility. And there you go. So that's how, and that's how you would, that would be, I guess, instead of entity, would be entity utility. But what's cool is you can keep setting the entity to different things. So you could reuse this utility, instantiate it once, and just pass to it, assign the entity to different entities on the runtime, and use it for all entities and get their their components. Now here's why I chose this. Is this get components by type was one function of many that I wanted. I wanted to see if the other methods that I wanted was has component, just simple give me a bool. Another one was has composition, which I passed it an array of types, and that array of types it'll go through and make sure that it has every one of those different types. So object-oriented programming won out on this one because I was able to, and I don't know of everything that we're going to extend it with, right? I don't know what other utilities we're going to need about pulling data out of entities, so I thought this would be the best way to do it.
Yeah.
And it's all in one spot versus the procedural, which you'd have a bunch of different functions and you'd have to pass an entity in as well many times. Every time you use the function, you have to pass it in, whereas this, you can see, we only pass it in the constructor and then we just call all the different methods on it.
That's probably the biggest difference between OOP and procedural is that in procedural you have to pass the entity along every time.
That's the state. You're passing in the state every function call.
Yeah, but in object-oriented, you can actually attach the state to specific instances of function calls. Instances of functions.
Yeah.
So you don't have to pass it in all the time. In fact, Python makes this really explicit. When you're defining a class in Python, you have class functions, instance methods.
Yeah.
The instance is always the first parameter that's passed into any instance method, and that's how you know it's an instance method.
Oh, is that right?
Yeah.
You can't get around that. It's like the context isn't there.
The state is passed into the first one, and it's explicit in the function signature. So that's just two different ways of looking at it. However, to do this sort of thing in a functional paradigm, how would you do that? Would you just have to curry it over and over and over and keep blessing that thing with additional functionality, or would it just...
I have to think about that. You put me on the spot there. Sadly, I don't think we would probably actually make another function for the has. See that you just wouldn't get that kind of reuse. It wouldn't be as effective because most times you're gonna have to pass an entity every time you're gonna be making these. You'd probably do the double invocation most of the time. In this case. So I don't see functional programming actually winning out in this case. Maybe, hey, if there's anybody that's really good at functional programming, please make some comments about how we could reuse this. I was just thinking of a silly example of currying, and I'm sure there might even be a more pure functional concept that we're missing here.
Neither of us speaks Haskell or Erlang or any of those very well, so
We just know of him.
we know of it. So yeah, I would like to see the functional implementation of how you solve this
That same
problem.
issue.
Keep adding the
Because it
methods.
seems to me like procedural and functional would be the same boat.
Yeah, which probably means there's something about the functional paradigm that we don't understand. And we're just,
For sure.
that's the thing about functional, is that you all of a sudden have to look at all of your problems backwards. And,
Yeah.
I'm just not very good at it yet.
Yeah, I wonder, I would really love to see some examples that would help solve the same problem. It would be really cool if Eric Meyer saw the video and told us we're a bunch of morons, and
Yeah, if you know him.
let him know about this video and have him comment about how to do this functionally, because he's the functional guru.
Yeah. So I guess the moral of the story is we want to have all these tools in our belt. And like we pointed out here, even on the procedural and OOP ones, this filter idea where we're passing in a function that gets invoked for every item in this components array,
Uh-huh.
that's kind of a functional idea.
That is a functional idea.
It's snuck its way into our OOP, and we really love that. And
That's just like, don't be pure, right?
right.
Don't go and think you have to make your JavaScript look like Java, since they don't have these methods, and I think they do now.
Yeah, they're coming along.
They're coming along. But the point is use the best tool for the job. And if you were to rewrite this with the for loop, it's a nightmare. You've got all this, you've got this array outside the for loop that you're augmenting, and then you're going to return that. You got the for loop, and it's just so ugly. I have a hard time with it.
But on that case, it's actually sometimes there is a reason to use a for loop, because this costs more.
Yes.
Because you have to invoke the function
Every time.
single time. A for loop is way cheaper.
There are times, like for example, in the game engine I built, that I found that the for loop was faster, and so I actually converted it back to the for loop. Then I found that all these JavaScript engines though are able to optimize these further, knowing that it's functional and there's no side effects.
Mm-hmm.
So if you don't have anything reaching outside of your scope of that filter, so if there's no leaky stuff,
Yeah.
they can optimize it pretty fast. But it's conditional, whereas the for loops are consistently fast, predictable.
Guaranteed faster. But we should say that kind of optimization is necessary in very, very, very few cases.
Like rarely. I think I even wouldn't put them back as filters because I found out that
It didn't matter.
it didn't matter as much. But there might be one or two, like with the collision system, where I still did it
Mm-hmm.
where I needed to.
Yeah.
Anyways, I think that describes all the different paradigms. If you have any even better advice for the different procedural, if we did it differently, I was thinking on the procedural for the greeting, if we go back to that, I realized that we could have just used languages as a global, because then you would have done that instead of passing it
Oh, that's
into
right.
a greet. That lanes could have been just global and scope globally. What you do a lot in C. So, but
yeah, we just like to keep things in the box.
yeah, and that really bothers me with my global policies.
Yeah.
So
And these are not the only three paradigms either.
I'm sure there's more.
There's more. These just happen to be the ones that we know about. So I hope that was helpful. Ask questions in the comments. Subscribe if you like to get more. And we will see you next time.
See you guys.